Hi there. In this video, I would like to talk about porting an old BASIC game to a modern programming language, in this case Java. And this game is Super Star Trek. It's a very cool text-based strategy game from the 70s. But before we get into the thick of it, let me give you some context. So, in the past, there was no internet, and the way that you got games, even before you could buy them in some form of media like floppies or even tapes, people would have these magazines. So you'd go to the bookshop, and you would get a magazine like this one, and you can see that here they had just the code listings, and then you needed to go back home and type all this crap, sometimes several issues of it, until you could play a game. So a while ago, I was reading the blog Coding Horror by Jeff Atwood, and Jeff was calling people to help port to modern languages, Java being one of them, basic games from a seminal book from the 70s that he claims started his career in computing. And that I can relate to that. This kind of magazine got me started first in computing, in 8-bit computers a long time ago. So I thought I could give a shot at porting one game, and I chose Super Star Trek. And I would like to share with you a bit about the process that I followed to get from the original basic code to a modern Java code, and the steps that I have taken.
So let's start by going to Jeff's GitHub repo and looking at the source code of this game. So there's 100 games, and we want number 84. That's Super Star Trek. And here we have the basic code. So before we even think about porting this thing, we should try just running it from basic code. And I will use the vintage basic interpreter in order to do that from my Windows PC. So here we are at the command prompt. We are in the directory where we can see the source code in basic. And I'm gonna use the vintage basic interpreted in order to run source code. So this is the opening screen, and we see a nice ASCII art of the enterprise. And this is the display of the current quadrant. The galaxy is divided in sectors and quadrants. So we see here the enterprise and just a bunch of stars. And here we see some status information about the enterprise. And you can see that we have a number of commands here. Navigation, which is to move the enterprise. Short range sensor scan, it's this screen. Long range sensor scan, this shows what's around us. So then we can navigate. You see we are now on a different quadrant, and we can keep moving. And you see here that right now we are in a quadrant with a Klingon. So this is a Klingon ship. Our goal is to get rid of them. There are 19 of them currently in the galaxy. So now I'm going to use the phasers, and I'm gonna fire like a 1000 energy phaser shot. And I run the short range sensor scan again, and we are with one fewer Klingon in galaxy. So you have star bases, you have a number of other commands to raise shields or to consult a library computer or fire photon torpedoes. But this is sort of a very quick overview what this game looks like and feels like. So now we can come back and really take a look at the source code. So first it will print that introduction ASCII art, and then we have a bunch of variables being declared. So this is very, very common in basic programs, that you declare pretty much all of your variables beforehand. And this had to do with the fact that certain regions of memory, lower addresses in memory could be addressed faster by the CPU. So typically you start out by simply defining everything beforehand. So it's just you have marginally a better performance. So that's something very common. Also, yeah, basic variables, they are limited to 1 or 2 digits. So the variable names are like P0 or P or T. And here we have some matrices named G, C, and K. So this is not terribly informative, but yeah, we're gonna have to figure out what they mean. So you have a bunch of variables being defined, and then we have a comment here saying this next code is about setting up what exists in the galaxy. And by the way, you see that comments are not very prolific in BASIC, also because of memory constraints. So all the comments that you are putting here, they are consuming a storage space, a memory space for your program. So they were very sparse with this remarks or comments in code, but thank God we do have some here. So we can see that this is about kind of initializing what exists in the galaxy. And probably we are kind of creating Klingons and stars and star bases and defining where the Enterprise will start at the game and so on. And then we have a part that prints your orders. And every time you enter new quadrant, so this is sort of the logic to show that short range scan and that status and take a command. And you can see that sometimes we do a goal subroutine. So this is really, we are kind of calling a function, right? But functions are not named in BASIC. So line 9030, we would have to come here to line 9030 to see what happens. And this is to show the quadrant name or the region name. So this will, you see, based on the content of a variable called G2 oh, I'm sorry, based on the contents of a variable called Z5 and Z4. These variables, we show different names. Uh, and this function, it's not named, and it's also, you cannot give it like any input parameter, so it's all global variables. And this is what makes very hard to read basic programs when they start getting long like this one. But we established that at the beginning the code is initializing some variables and then getting into this loop, and it calls several subroutines. And if we start looking more at the code, yeah, here it's where we print the command, the different commands that you can choose. And then we see a lots of go sub and go tos around, like here. So this is like controlling the flow and sending you to different parts. And if we keep exploring this, we see that things like, oh, this is a subroutine where Klingons move or fire on your starship. And this is a subroutine to move your starship. And then we have for the different commands, we have like, this is for the shield command, how you handle that, and so on and so on. So of course we're not going through all the about 500 lines of code that we have here, but I just wanted to give you an idea that the main sections are setting up variables that represent the status of the game, starting a loop that you keep repeating of taking a command, fulfilling the action of the command, and rinsing and repeating. And then we have several subroutines, which are the different commands and some parts. Some of these commands are complex, so you have multiple subroutines for them. So question is, how do we go about porting these to Java? So in theory, you could read the program and make notes and understand how it works. And then you could simply code it from scratch in Java. I don't think that's a very good idea. It's very easy to get lost in the details here. So what I propose is to take this porting in stages. So Stage one would be simply to have as much as we can the exact same code, but in Java with Java syntax. Of course, you cannot do everything exactly the same, but you can get kind of close to it. You can keep the variable names exactly as they are, and you can try to, as closely as possible, have a line by line translation in Java. And that will help you ensure that you are porting all the elements of the game. But of course, you are kind of missing the point of having it in Java, which is to be able to express the behavior of this program in a way that's simpler to understand and simpler to maintain. So the second step in our translation journey would be to really enhance the original kind of literal translation with larger variable names that will capture the content of I mean, what each variable is containing, and renaming some of the functions and simply cleaning code around. And that will give us a nice set of different methods or routines with better variable names that we can understand better. So that's already quite an improvement. And then we go finally to the third and final step of this porting, which would be to really express the game in Java as opposed to a simple translation, but really use classes and use the object-oriented thinking that's behind Java. So let's take a look of what the code looks like in these three stages: the literal translation, the enhanced translation, and the kind of a transliteration in Java, or a new creation of the game in Java. Okay, so I will not bore you with the whole process of actually creating the Java code. This has taken me many hours. Over, I think I've been working on this for a month or so, not every day, just a few hours, a few days in the week. Yeah, this is a hobby and not my main job, right? But finally, I got a literal translation going on here. And you can see that we start out by defining all those variables that define status. And I started putting comments here that help me understand what these things are. Because as you start working through the code, you start understanding that, for instance, this matrix K contains the position of the quadrants where you have Klingons. And it's a 3 by 3 matrix. And you have like the entire galaxy map, and you have many other things like the current quadrant and sector that you are, and the total number of Klingons and star bases in the universe, and so on. And I try to keep also, I started out with all variables mapped as constants, so I could really understand which ones were constants and which ones were changing during the game. So they are all globals for now, but we're going to improve this in later versions of the game. So you see that this is the equivalent of that initial part of the basic code where we just set up a bunch of variables. And here we start the game properly. We print the banner, right, with the ASCII art, and then we start going to the game setup, and we just init the enterprise position. So we have some functions here that are defined in the original code that basically you have random numbers being generated. So you're just putting the enterprise randomly somewhere in the universe. And then on your loop, you every time you enter a new quadrant, you init some variables, and then you call some sub-functions. Those were those goal subs. For instance, this one was for getting the quadrant name. You recall there, though, it was putting the quadrant name in a variable called G2$, and I'm keeping these weird basic names here so we can find our array and we can easily compare the basic code with Java code. And here we have the logic depending on the content of these Z4, Z5 variables. Here I'm explicitly passing all the variables that you need here so I can understand what is really needed from this function, whereas in BASIC you might recall it was just a bunch of goal subs using global variables. In some cases here, I had to change a bit the logic. For instance, in BASIC, it's very common that you have, when you have a branching logic based on a condition, like you say, if true, then if a certain condition is true, then I do this bunch of commands, and if the condition is false, then I do a bunch of the other commands. So the typical construct in BASIC for doing that, because in BASIC you cannot say if this is true and then do a bunch of commands. You can only, have like a few commands after the if. They have to fit in the same basic line. So typically what you do is you reach a certain point, as you said, if this condition is false, then I go to a line that's ahead, that's kind of 10 or 20 lines below. And well, if it's true, you will simply not get redirected with the goto. You're simply going to process the true condition in the, let's say, the next 10 basic lines, and then you when you get to the end of the true section, you just make a goto after the next section of the branching code. So you see that you're really using gotos to do an if else when you have several commands. In my case, I'm just doing this if else's when it makes sense. So this is really a simplified version. And here's the command loop. Basically, we are showing that short range scan and taking the next command, and then we go to a different function. And this is basically all these things were in the original source code. For instance, you had a subroutine for navigation, and you go here to navigation and you do all these weird things. And at this point, it's hard to say that I mean, this code is completely understandable. And by the way, I made some comments here tying back to the original basic source code line, so I could find my way around. So when we have a go sub to 290, we are actually calling this navigation subroutine. And yeah, it's kind of still slightly cryptic what's happening inside each one of these functions, but later when we change the variable names, this is going to improve a lot. And also you can see here some Java methods that look a lot like basic commands. So also to make my life easier, instead of every time writing system out print line blah blah blah, because then it looks very different from the original source code, I just created a print function that does that. And also I created a function for casting a number, a decimal number to a fractional number to an integer, and to print multiple spaces, and to calculate the length of a string, and to have inputs. All these things that they exist in BASIC, and string manipulation commands, I just created sort of equivalent. So the code it's more of a literal translation, and it can be easily compared with the original. And this way I can make sure that it's all running and looking as it should be. So for instance, if I run the command, the program here, you see this is what it looks like. And you can see that we have basically, it's very similar as it should be rendering of the original program. And this is what the source code looks like. I will leave links to where you can find my entire source code so you can take a look at the details. But the main idea here is that we start from the basic source code, and then we create Java code, or it could be a different programming language, but we create a new code that's as close to a literal translation as we can, so we can compare if the behavior is exactly the same. And from there we can go to something that's departing a bit from the original program and using longer variable names and using other constructs that we have in a more modern programming language. Okay, so now we can see another step in our translation process, which is an extended translation. So this is not yet like a pure Java program of sorts. It's still not really object oriented, but it's an improvement. It's sort of an extended version of the literal translation that we have performed in the previous step. And you can see how, I mean, we still start by defining variables, but now the variables are much more descriptive. And also, instead of during the code, we are using constants for instance, the ASCII art that represents the enterprise or Klingons and so on. Instead of just repeating these things as strings during the code, we are actually referring to these constants. So things get much more descriptive. So you see here we define a large number of constants for the different markers of things in the quadrant, and the commands for the command 1, 2, 3, 4 are actually named as command navigation, command short range scan, command long range scan, and so on. Same for some submenus, and here we have devices that are part of the enterprise. They just have numbers in the original program. Here we really are defining constants for them. And the game state here now, we have yeah, pretty much the same matrices and yeah, integers and strings, but now they have much more descriptive names. You can see that I have even kept some notes here so we can map the original names in case we need to check something in the original source code. But this is much better. And you can now the code is much more so in its enterprise position. You see that we are saying here, okay, that the the current quadrant and sector, we are just calling uh, random a function to generate a random integer between 1 and 8 inclusive. And when we set up what exists in the galaxy, we can see here we are setting Klingons, and we are setting bases and these things. When you enter a new quadrant, you can see better what is going on. Here the command loop, right? We check, we get a command string, and depending on whether it's navigation, short range scan, long range scan, we call the corresponding subroutine. You see now I'm using, in some cases, globals. In some cases, I'm actually passing the variables. And this is a new improved version. You see, yeah, I mean, this logic with the original variables, like just, x1, x2. I mean, it was really hard to understand what was going on. And here yeah, this is really kind of finding the distance between an xy uh, original coordinate and an xy target coordinate, and what is the cardinal direction. So the code is much more uh, readable now, and we can reason about it better. But still, it's fundamentally the same kind of literally translated code, or almost literally translated code, but with just better naming. We are not yet on the third step, which is really to create this in Java with object-oriented thinking, which should be our next and final step. So then we finally arrive at the third step of this porting, which is an object-oriented port. So here I got, instead of having one big source file that contains the entire code for the game, we have divided it in different classes that have different responsibilities. So to be fair, this is still a bit sketchy. I mean, if we were designing this from the ground up, probably we would land with many more smaller classes with uh, uh, narrower responsibilities. But yeah, the truth is we are starting from a monolithic code, from just this big code with global variables. So this is already an improvement, and it's kind of showing the idea of object orientation. So as I mentioned, we now have well, we still have the class uh, for with the game, but now we see that it has been stripped of much of its responsibility. It's mostly about parsing the commands, showing the cosmetic screens, and depending on the command, we can either have the implementation here, but in most cases what we are actually doing is delegating to other classes. For instance, if we take the long range sensor scan now, it's actually performed by something called the galaxy map. In other cases, we have the enterprise class with this responsibility. For instance, damage control, we have a class called enterprise. So the game class knows about all the other classes. However, the other classes are more limited in scope. For instance, the galaxy map represents the galaxy with all the things that are in the galaxy, including stars, starbase, Klingons, and of course the Enterprise. And it knows how to render those short and long range sensor screens. And it has the state of yeah, the different sectors and quadrants, and it renders what we have in each one of the quadrants when we enter them. And in many cases, it delegates responsibility to the class enterprise that represents the ship. So the class galaxy map does not know about the class game, so it's decoupled from the class game, and but it knows about the enterprise class. And if we go to the enterprise class, this really, as we should expect, represents the starship itself. And here the different devices of the starship and its position in the galaxy, and the status of the ship, whether it's docked or not, how much energy, torpedoes it has, etc. And it has intelligence to do things like increase or decrease energy or torpedoes, and position itself in different quadrants, and the logic to move the ship from one place to another. Actually, part of this logic is the galaxy map, and part of it's in the enterprise class. But you can see here that instead of one big class with more than 1,000 code lines, now we have 330-ish on the enterprise, and about the same for the the game class. And then we have the galaxy map, that's the largest class with about twice the number of lines of code. Also, we do have a util class that contains all those utility methods for dealing with strings or getting user input, or rounding numbers, or getting random numbers. And yeah, we still have a class with just the instructions. One interesting thing is the question of dependencies. I mean, because this was originally made as one big entangled program, then sometimes it's hard to properly decouple things. So it was very easy that we would make the galaxy map have visibility of the game class, which is something that I didn't want. But you have, for instance, some end game scenarios that you can only calculate from within these methods. For instance, when the Klingons are shooting, it may be that you're just run out of hit points, and then your game ends. So what I'm doing here is that I have this interface called game callback, and this has only 4 methods that are needed from within the other classes, from Galaxy Map and Enterprise. And the game class implements this game callback, and in some cases it passes itself. You see, for instance, for the Klingons move and fire, we we pass a class that satisfies this interface. In this case, it happens to be the game class itself, but it could be something else. It could be lambdas. So we really are decoupling. So we are giving hooks so that the enterprise and the galaxy map classes can call logic in the overarching game class, but without creating a direct dependency. So that was it. Of course, the code is available on GitHub. If you are interested in getting more details, feel free to get in touch. I would love to talk some more about this. Please let me know what you think. And yeah, I really think Jeff Atwood has made a nice challenge, uh, asking for people to port these old games to several modern languages. I think there's much to be learned from there, and also to sort of keep this legacy, which is has both a nostalgic and also uh, I think it goes beyond the nostalgia, and it's really we have something to learn from this still to these days. So that's it. Thanks for bearing with me, and see you next time.